This is question 26 on chemistry from the 2018 BMAT. So we're told that at high temperature and pressure, xenon gas reacts with fluorine gas to form xenon hexafluoride gas, and that the overall energy change for this process is minus 330 kilojoules per mole, and the FF bond energy is 158 kilojoules per mole. So what is the xenon-fluorine bond energy? So where should we start? Well, why don't we write down the reaction that's happening? So we've got xenon gas reacting with fluorine gas. So maybe we can assume xenon in the gaseous state is just a xenon atom because it's a noble gas. We know that it's not very reactive, so it probably exists by itself. We know fluorine gas is F2, and we're forming xenon hexafluoride, which tells us that it's XeF6. And we need 3 fluorines to make 6 fluorines in the product. So what can we do with this? Well, with these thermodynamics questions, it's always good to do a sort of Hess cycle. And so what else can we include in this cycle? We're told that the FF bond energy is this, so we need to break these FF bonds. So let's do that. This gives xenon unchanged, but we have 6 F atoms rather than 3 F2 molecules. So we have a cycle. Now let's put some numbers in. So we're told the overall energy change for the process is 330, or minus 330. And that's this, because this is our reaction. And we know the FF bond energy is this. So we've got 3 bonds that we're breaking, so we need 3 times 158. And have we got the sign the right way around for this? Well, we know that breaking bonds requires energy, so this is going to be a positive value because we need to add energy to the system. And what about the last thing? Well, this is the value that we need. That's the xenon-fluorine bond energy. And we're forming 6 xenon-fluorine bonds, so this is going to be 6 times xenon-fluorine bond. And it's minus because we know forming bonds releases energy, so this is going to be a negative energy process. So what can we do with this cycle? Well, what does Hess's law tell us? We know that the energy change for a process is independent of the route taken. So equally, this path is the same energy as this path. So how can we use this? Well, if we use our numbers, we can say that minus 330 is equal to 3 times 158 minus 6 times the xenon-fluorine bond. And we want this value for the bond energy, so let's rearrange it. To give 6 xenon-fluorine bonds is 3 times 158 plus 330. Let's simplify this down, so dividing everything by 6 gives 158 over 2, because there's already times by 3, plus 330 over 6. And 158 over 2 is 79, and 330 over 6, well, over 3 would be 110, so over 6 is 55. And this comes out as 134 kilojoules per mole for the bond energy of the xenon-fluorine bond. So our final answer is C.